Hello. Yeah, good morning. Good evening to one and all. Yeah, my voice is audible. Hi, good evening to one and all. My voice is audible or not? Please respond by typing hi in the chat box. Yeah, good evening, Vikash. My voice is audible. Yeah, good evening, Jilan. Yeah, today lecture is on the information theory. Are you getting my point? Yeah. Are you having any basic idea about the information theory? Do you have any basic idea about the information theory, Vikash? Okay. Yeah. First point we are going to discuss in the information theory, like what is information, what is entropy, what is information rate, what is channel capacity, and some of the basic points we will discuss. Are you getting my point? Yeah, first point, let me explain what is called information and how this topic is important in our communication system. We will get back. If you take the overall communication system, generally in our classrooms we might be studied one transmitter, one receiver, one transducer, like that. But practically in communication system there are number of blocks will be there. In communication system there are number of blocks will be there. There's a lot of data will flow from one block to another block. Are you getting my point? So there we need to measure how the information is flowing between the different blocks. Getting my point? Yeah. Here information is denoted with I of x. So before getting to this point, what is the base point taken for the information is students? Suppose if the event is occurring more, then it will have less information. If the event is occurring less, then it will have more information. Just like, for example, let's take one daily activity. So it is regularly happening. Is there any special news in that? Are you following my point? Suppose if you take any regular activity, is there any special news in that? Are you following my point? Yeah, please respond. Yeah, because what I'm asking is, if anything is regularly happening, is there any special news in that? Suppose if you take any event, suppose just take your birthday. Birthday will happening only once in the year. Then definitely in that day we will feel some special. Are you understand my point or not? So here, whenever the probability of the event is more, whenever the probability of the event is more, then it will have more information. Are you following my point? If the probability of the event is less, then it contains very less amount of information. So if you denote the information with I of x, I already shown there. So information I of x. information I of x is directly proportional to 1 divided by probability. If the probability is more, then it will have more information. If the probability is less, then it will have more information. Probability more, less information. So to avoid the proportionality, we are taking a constant. So I of x is equal to, what is the proportionality we taken is log. So log 1 by p of x. This is the formula for the information. Here, based on the limits, based on the base, the units for the information is going to be varied. Suppose if the b value is base is 2, then what is the units we are calling for information is bits. Are you getting my point? Suppose if the base is e, we are measuring the information nats. If the base is 10, we will say the information is decits. So depending upon the base, the units for the information is going to vary. So throughout in our communications, in our information theory, whether they mentioned or not, the base is always B only. In our information theory, whether they mentioned or not, always the base is 2. So we'll measure the information in terms of bits. So throughout the information, that is fixed. Are you following or not? The base units for the information is, if you take the B, then the units will be the bits. So after learning the information, all of you got the point? Yeah, please respond. Then only I can proceed to the next topic. Are you got the point of information? Let's take one simple example. Suppose students, suppose I have one transmitter. This transmitter is having, for example, 3 symbols. This transmitter is having 3 symbols. Like you can take x1, x2, x3, like it is having 3 symbols. Yeah, boss. What I'm saying is, if the probability of the event is more, then less information. If the probability is less, more information. Just like if you take any regular activities, nothing to discuss in that. Suppose if you take your birthday, that comes only once in the year, then obviously the special thing in that. Are you got my point? Yeah. So let's take the first question, question number 1. A transmitter is having 3 symbols like x1, x2, x3. Probability of x1 is given 1 by 4. Probability of x2 is given 1 by 2. Probability of x3 is given another 1 by 4. Total probability should be 1. Now he is asking, calculate the information associated with each symbol. Calculate the information associated with the each symbol. That is a question they given. So how to calculate the information, sir? We know information I of x is nothing but, what is the formula? Log base 2 1 divided by probability. Suppose if I want to calculate the information of x1 symbol, so p of x1. that is nothing but a log base 2 1 divided by, what is the probability of x1? Probability of x1 is given 1 by 4. So it is nothing but log 4 base 2. Log 4 base 2 means it is nothing but 2 bits of information. That is a way of calculation. For example, if you want to calculate for second symbol is x2. Formula is log base 2 1 divided by p of x2. What is the p of x2 is given 1 by 2. So it is becoming as log 2 base 2. Log 2 base 2 means it is nothing but 1. So 1 bit of information. That is, you can observe probability of x1 is 1 by 4. Probability of x2 is 1 by 2. So x2 is having more probability, so less amount of information. Less probability, more amount of information. Like, you can also calculate for the I3, that is nothing but a log base 2 1 divided by 1 by 4. So it is nothing but log 4 base 2. It is also 2 bits of information. A simple question. These type of models are also asking in the ESE examination. So here what I discussed, simple, I given the information theory, information formula in the information theory. So, and I taken one simple problem where I calculated the information of 3 different symbols. All of you got this problem? Anyone having doubt in that? Yeah, guys, please respond. Then only I can forward. So voice and audio and video is clear? Anyone having any problem in that? Clear? Yeah, you guys try, please try it. In the second problem, for example, I am having 2 transmitters. Let's take this is the transmitter 1. It is having 2 symbols x1, comma x2. x1 probability 1 by 2, x2 probability 1 by 2. Calculate the information rate. Calculate the information. Means you can simply calculate I of x1 as well as I of x2. Just simple thing. So both how much you are getting? In this question, yeah, definitely. Here you will get 1. Here also you will get 1 bit of information. So the simple question and calculation of that. Next, move forward. The next concept is, students, very, very, very important. Every year one question is coming. What is that is called, students? Entropy. Entropy is very, 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 very important. What is entropy, sir? Entropy is called, students, average information. What is entropy, sir? Entropy is called average information. So entropy is denoted with, sir, entropy is denoted with h of x, or simply you can say entropy is denoted with h. What is the units, sir? Units for entropy is average information, so bits per symbol. Bits per symbol. Any doubt? So what is the entropy formula? Entropy H equal to summation I equal to 1 to n. Here the meaning of 1 to n is, for example, 2 symbols are there, 1 to 2. 3 symbols are there, 1 to 3, like that. P of xi means it's a probability into I of xi information. This is the formula for the entropy. Very, 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 very important. So what is that? This is equal to, you can also write summation I equal to 1 to n P of xi into log 1 divided by P of xi basis 2. Or this you can also write as, if I write in the numerator, then it will be minus summation I equal to 1 to n P of xi into log P of xi. Base is always 2. This is the formula for entropy. Very, very, very important. Entropy means it is called average information. Are you guys following or not? So every year in the GATE as well as in the ESC examination, one question is coming from the entropy. So all of you understand that formula? Yeah, guys, please respond. Yeah, please respond. You got the point or not? Response is important. Yeah, if completed, let's take one problem. For example, let's take this question number 3. For example, we are having one transmitter which is having 3 symbols x1, x2, x3, having the probabilities 1 by 4, 1 by 2, 1 by 4 respectively. Then calculate average information or entropy. Average information or entropy is nothing but the same. Yeah, you can download the app. You can download the app. You can enjoy the recorded classes completely. So total theory I taken as well as all the GATE problems up to 2020. From starting onwards up to 2020, all the GATE problems I discussed there. And if you want to get some discount on Unacademy, you can use the code Naidu 10. Naidu 10 on Unacademy on Ekeeda subscription. To get the Ekeeda subscription, 10% discount on Ekeeda GATE subscription, you can use that code NIUDU. Are you getting my point? So anyhow, you will have a doubt lectures. You are having doubt lectures and complete recorded classes are there. And recorded classes are very, very excellent. Some of the free demo videos are also there in the Ekeeda YouTube channel. You can also enjoy those. And all the GATE problems and some of the ESC problems are taken. Are you getting my point? Yeah. So for that question, we need to get the entropy value. How to calculate, sir? In the above itself, I given entropy formula. So H equal to summation I equal to 1 to 3, because 3 symbols are there. If you write in the P of X above, you can take the minus sign. Probability, that is first symbol 1 by 4, log probability 1 by 4, because I already minus written, plus second one. Directly the summation I am expanding. Are you getting my point? Next one, 1 by 2, log 1 by 2, plus 1 by 4, log 1 by 4. Here calculate, to avoid that minus, all I can write in the numerator. So 1 by 4 log 4 base to 2, 1 by 2 log 2 base to 1, 1 by 4 log 4 base to is 2, then it is becoming as a 3 by 2. Information is bits per symbol. Got the point? So every year the question is coming from the this entropy concept. I will give you one question. You can guys try it. Suppose we are having one transmitter, two symbols, x1 and x2. Probability of this 1 by 2. This probability also 1 by 2. Calculate what is entropy. Second question. There are two symbols are there, x1, x2. For this one, 1 by 2. Sorry, for this one, 1. For this one, 0. This probability is 1, that probability is 0. Then here also calculate the entropy. This is the question. So in those two examples, calculate the entropy. Are you following or not? Guys, please respond. Abbas, are you following? Yeah, Bikash. So I given the question, transmitter having two symbols x1, x2. First question, both are having 1 by 2 probability, what is entropy? Second question, 1, 0 probability, what is entropy? How or what is the logic you got from those two examples? And what is the point you got from those two? Yeah, definitely here. What is the entropy value you got? Entropy is 1. Here definitely what is entropy you got? 0. Why? Why it is like that? Why here entropy is 0? Why here entropy is 1? And what is the point you observed from there? There is a very, very important point you will get, guys. Very, very, very important point you get here. here you got the probability 1. This itself is the H max value. So here H max is 1. Here this itself is called minimum, of course 0. Entropy cannot be negative. What is the logic here is, if all symbols are having equal probability of occurrence, then you will have maximum entropy. Entropy is also the measure of uncertainty. What is the meaning of uncertainty? For example, let's take the example of a tossing a coin once. If you toss the coin once, if it is a fair coin, then probability of head and probability of tail both are same. Then we cannot expect what is the outcome exactly. The same situation if you take in another model, suppose I am having a coin, both sides it is having head only. Both sides it is having head only. If I toss that coin, then obviously head only will comes. Means the uncertainty will be maximum whenever all symbols are having equal probability of occurrence. All symbols are having equal probability of occurrence. If the symbols are having not equal probability, obviously uncertainty is less. Are you getting? So I can give direct formula for H max also directly. If for example, if source is having m symbols, all are having equal probability, all are having equal probability, then what is the entropy is nothing but simply entropy is log m based, and this entropy itself is the H max value. Suppose if we are having two symbols, log 2 based, that itself is 1. For example, 10 symbols, log 10 based. So whenever all are having equal probability, then entropy is maximum value is like that. You need to calculate, at least shortcut itself. The next point you need to understand, after the entropy, from the entropy, there are number of gate problems are there. I solved all the gate problems. You please watch it by taking the Ekeeda GATE subscriptions. Use the code NAIDU10 to get maximum discount. And some of the free lectures also there in the YouTube. You can also see it. The next point is you need to understand what is called information rate. What is called information rate? Information rate is R. Always rate means you need to understand per second. What rate information? So it's nothing but bits per second. Are you getting my point? Rate means always per second. What rate information? Information means bits per second. So it is denoted with R. R is units are bits per second. So it is nothing but I can write bits per symbol into symbol per second. Are you following my point? Yeah. So bits per symbol is nothing but entropy. Symbol per second is called symbol rate, that is denoted with a small r. So finally capital R information rate equal to H into small r, where small r is nothing but symbol rate. This is also important one. You please remember the formula. Any doubt? Anyone having? Guys, please respond. Where H is the entropy, small r is the symbol rate. Anyone having any doubts? Next one is channel capacity denoted with C. Next one is channel capacity denoted with C. Here units are also bits per second. Here units also bits per second. And what is the difference is, for example, here this is the transmitter and information is flowing through channel. What is or how many bits generated by transmitter per second is given by R. How many bits carried by channel per second is given by C. Where R units are bits per second, so C units are also same bits per second. So C will give you how many bits carried by channel per second, and R will give you how many bits generated by transmitter per second. And here we are having one thing, that is channel capacity theorem. Also called Shannon-Hartley theorem. What is that? Channel capacity theorem will give you the relation between capacity of a channel to its bandwidth. C equal to B into log 1 plus S by N, base is 2 only. Where B is called bandwidth of the channel and S is called the signal power expecting at the output of a channel. N is the noise power added in the channel. And here, for without any information loss, the suggestible thing is C should be greater than or equal to R. Generally, capacity of a channel should be more when compared to the information rate. And here one more point you will get, that is called efficiency of a channel. That is nothing but R divided by C. This is also number of times asked. And number of problems also we got from the channel capacity. Yeah, how many of you guys following? You can please respond with a hi in the chat box. Guys, please respond. Anyone having any doubt? So anyone having any doubts in taking the Ekeeda GATE subscriptions? You please call to this number for the more details. Thank you.